I am Filip Marshal. I work in Proximus NXT for the cloud practice. I lead a private cloud team. And I will be here on stage together with Marc and Manon from FarmaFlux APB. Join me. Great to have you on stage with us.
Thank you.
Thank you.
Morning.
And we will speak a little bit about the pharmacy landscape. So, a question to you guys. The pharmacy landscape, we have more than 4,500 community pharmacists in Belgium. They employ 16,000 people. And did you know that 500 patients visit a pharmacy every day? So this morning I went to the doctor. I asked, she happens to be my wife, so I still have access to this. I think everyone still remembers this one, the paper recipe prescription. You would typically go to the pharmacy, you hand out this prescription, pharmacist would give you your medication, and what do they do with this one afterwards? They put it in a file or they throw it away, I don't know. So today we're going to learn a little bit what the journey was, how this changed, how this environment changed throughout the years. I think Manon will explain a little bit what is FarmaFlux then.
Thank you, Filip, and good morning, everyone. FarmaFlux was actually created 12 years ago, and it's an association created by the 4 professional associations of pharmacists and pharmacies, APB, OFACO, VAN, and AUP. And the most important thing for creating the association was to be sure that every pharmacist was represented in FarmaFlux. And every pharmacist is connected to one of those associations. So that's why FarmaFlux was founded. Now, there were 2 main reasons to found an association like FarmaFlux. And the first reason was that there was the wish that wherever you go in this country as a Belgian citizen, you should have access to the same level of pharmaceutical care. And the second reason to create an association as FarmaFlux is collaboration. Collaboration. If you want to innovate, make innovative things, then you have to collaborate, you have to work together, you have to unite the forces. And that's exactly what we did, Filip, with FarmaFlux.
Yeah, indeed. Thank you. So throughout this slide deck, the next 26 minutes, we will take a step back to 2009 when this paper prescription was still active and how we got into the digital realm. And we will give also some highlights on how we worked with FarmaFlux, how their business evolved also, because it was a nice story there. So I think Manon will explain now during a small movie what happened.
Yeah, so we had quite a journey, and one of the first services that was developed was the shared pharmaceutical records. As a pharmacist, it's quite important to have a holistic view on the dispensed medication of every patient. Wherever you go, a pharmacist needs to know which medication you take, because you might or you might not know. He can check on interactions, if you need a new prescription, if you get a prescription with a pharmacist who you don't usually go to. He checks if the box is the right box, if it has an interaction chemically seen. There are quite some things that a pharmacist does and needs to know to give you and dispense you the right medication. And therefore we developed the shared pharmaceutical record, because you've seen the prescription, the paper prescription of Filip. A pharmacist is also obliged to register every dispensed medication, every prescription he delivers, every preparation he makes. And he's obliged to make the registration in his local pharmaceutical record. And it's also, and that's why we wanted to make a shared pharmaceutical record, so that every pharmacist can have a holistic view on the dispensed medication. And so here's a little movie on how the pharmaceutical record works. Every medication that is dispensed in a pharmacy is registered locally in the local pharmaceutical record, but is also transferred to the shared pharmaceutical record. And day and night, 24/7, every pharmacist is able to check the whole history of your dispensed medication. So he can deliver the best of pharmaceutical care. And I think Marc will now explain you a little bit more on the technical side how this works.
Yeah, thank you. So you heard already some of the keywords. Now going back to the prescription of Filip, at a certain point Filip would like to go to a pharmacy. I don't think anybody knows where Filip is going to visit a pharmacy. Will he visit here a pharmacy next to this place at his hometown, at holiday place in Knokke? Filip, maybe you have there some place, the Ardennes, or when he does go for a city trip. So basically we don't know. For that we have opted for a central solution, meaning all data, all medication records, all dispensed medication are being centralized on one place, here referenced as the PCDH, Pharmaceutical Care Data Hub. There inside you can find also the data related to the prescription. The second part is we don't know when Filip is going to fetch his prescription. Directly after this meeting, this evening, during the night, during the weekend, we don't know. Very important, system needs to be up 24/7. So it's a very important element. Up being always and never down. So we don't have the luxury of having some maintenance interruption for a couple of minutes or a couple of hours. There are somewhere in Belgium at every moment there is a patient entering, the pharmacist requesting some guidance and some help out. Even further on the element of let's say let's do an intervention or an interrupt during night. It's not possible because then the most important element is having that shared pharmaceutical record. Filip doesn't go to his own pharmacy. So the story there, Filip mentioned the prescription, and what does he do? He enters the pharmacy and he says, "Hey, I'm Filip, I give you the prescription to the pharmacist." Pharmacist will also ask his identity card, potentially if he doesn't know. What happens there? The identification of Filip as being a person is residing on the electronic prescription or on the identity card. So we know who Filip is. That triggers the full process of fetching the data on the dispensed medication. Okay, so we know that Filip has who Filip is. He has an identification number. We go to the central system, we knock to the door. Filip doesn't want anyway to have nobody or everybody accessing his data records, though there are some boundaries. Authentication and authorization. Authentication is based on the identification of the pharmacist working inside a pharmacy, and that authentication happens every day. Every 12 hours there is a renewal of authentication being addressed that the pharmacist working in a public pharmacy is authorized to access the ecosystem or the healthcare system in Belgium. That's step one, that's the authentication. We also have an authorization. Filip doesn't want that every healthcare provider has access to the system. So for that, Filip has given somewhere in Belgium his so-called e-health consent or the general consent to share medication-related information or in general medical information in Belgium. So we need to check whether Filip has given his consent. He even has to go further, or the checks for the authorization even goes further. Filip is only wanting that the healthcare provider having what's so-called therapeutic relation is known and is being observed. So he chooses a certain pharmacy. There is a so-called therapeutic relation. If there is a therapeutic relation, for instance, the execution of a prescription or visiting a pharmacy, then we have a proof of a therapeutic relation. So you need to be authenticated quite hard, as well as pharmacist, as well as pharmacy. You need to have an authorization. Filip needs to have been given his consent. There is a necessity for a therapeutic relation. Filip even has the possibility to exclude certain healthcare providers or pharmacies. If everything is well, the information from the PCDH is being transferred to the end user software. That's on the point to the right. End user software in Belgium, we have 8 software vendors integrating and offering solutions to the population or to the pharmacists themselves. 8 software vendors, they're all connected to the FarmaFlux system and they are integrating, or they have integrated full interoperability and connectivity to the system. They get the data from the central system into the local system, like we call here also refer to the shared pharmaceutical record, but into the operating environment inside the pharmacy. And it is necessary because the information centrally stored is not feasible for on the central system. Every data record in the system, every record on a dispensation is being encrypted with a key, being separated, managed by the public authorities. Meaning we cannot peep into Filip's data, we cannot peep into his medication history. Data are being retrieved from the central system and being stored on the local system. We fetch the keys from the public authorities. We do every dispensation decryption there, and then we have the shared, the medication history being shared on the central system available. All the interaction analysis and other types of actions happening on the dispense history is then the subject again to the pharmacist. Then we go further a little bit. Let's go to this side then. So Filip is happy, he receives his box with medication, should be helpful or not, Filip. And then whilst he's in the pharmacy, he says, give me some toothpaste. He says, okay, that's all I wanted to have. Okay, it's good. Filip goes to the counter, puts out, pays the amount, not the full amount on the medication, a part of the amount of the medication, leaves the pharmacy. Automatically, the system is being triggered again to say when there is a terminated dispensation, a finalized dispensation in the pharmacy itself, everything is stored locally in the local pharmaceutical record, and a trigger is being launched, being all data related to every dispensation in the pharmacy is being, let's say, secured and being transported to one of the other subsystems, called TIP, Trusted Intermediate for Pharmacies, meaning it's an intermediate prior to storage of the data. On the intermediate level, we get data in, we look a little to the data, is it quality rich, is it safe to have it as available for interoperability, because it needs to be connected to all software vendors and so on. And if everything is okay, we give a confirmation back to the software and we further treat the message. Okay, we are analyzing, we see in real time, this is a medication, that's good, because the focus was pharmaceutical care. We need only information on pharmaceutical care. Filip bought some toothpaste. Do we need it for pharmaceutical care? I don't think so. So what we do, we kick out that information, and the remaining information is again encrypted prior to storage, encrypted with the public key offered by the public authorities. After encryption, it's being put in the pharmaceutical care data. You see, round trip is available on the prescription. The pharmaceutical care data hub then stores the information during a period of 12 months, after which it's fully deleted. We end up in about 150-200 million records in the shared pharmaceutical record, and the number or the population, we're between 10 million and 11 million citizens known into the system. So it's fully deployed and fully operational, to give you some numbers. Now, being or having the availability and reassuring the availability, we opted for a double data center. So we have 2 data centers. We have Manon and Carly, Evre and Carly. Okay, so in full redundant mode, full operational. When one fails down, we just continue in the operation. I mentioned also to have 0 interrupt or always availability. Even in every data center, we have at least 2 application servers running. When I need to do some maintenance, I put down 1 application server. one data center and the two other application services of the data center. They're still up. I do the little maintenance and I go through all of the systems to reassure the 24/7 availability. Right.
Okay, top. Thank you, Marc, for this explanation. So, in summary, Proximus and FarmaFlux APB have worked on this since 2012. I think we initiated the initial setup. This is a technical slide. Needless to say that with all these increases in connectivity, in adding pharmacies to the system, the data that is coming in, we had to adapt, refresh the systems, check the requirements that everything was still fitting. So that was also a cooperation on that level. But then you started doing expansions, Marc, also. So can you explain a little bit about that one?
Well, the beginning was 2012. Let's get up some shared pharmaceutical record. 2014, it was up and running. That was on the timeline itself. Getting back, I mentioned that there was an action in the pharmacy that was a dispensation being terminated. Some data is being encapsulated and sent over to the central system TIP for further processing. Now, if you can put some data related to a dispensation into an envelope on a secure way in exchanging between the pharmacist and the central system, you can put something else also in the envelope or in the transferred mechanism. So we used the same secured environment from source and the pharmacy to the central system to also register and, let's say, exchange other type of data. The first one is the private insurance or Assur Pharma. For those who are a little bit more older or who have some, let's say, already in the past the necessity on the hospitalizatie, the private insurer, you need to collect all your bills during a period of 3 months, put it in an envelope and you send it over. This has been fully finished. So when Filip was again into the pharmacy, at the moment he wanted to pay, he says, I have a card of a private insurer, whether it's a DKV, an AG insurance, you name it. All private insurers, they have a connection to our system. What happens there is that at the point and at the moment of dispensing, it's not an asynchronous, but synchronous call is made to our system. I check the validity of the information and whether there is a conformity and quality-rich information. If it's okay, I attribute a number, a unique tracking number to the ticket. I send it back to the pharmacy and flip out of the printer. There is the ticket mentioning, well, you do not have to put it or give your ticket to the private insurer. If there is an issue, you have your tracking number. If they don't receive a tracking number from my side, then the full element is being printed out without the tracking number. Assur Pharma, all private insurers are connected to the system, and out of the central system, which I mentioned, the TIP, we do the diffusion. So to say, well, that needs to be encrypted and transported to a KBC, that needs to be encrypted and transported to an ETIAS, AG Insurance, you name it. Assur Card is also one quite active in the field, so that's happening. It's a service offered by the pharmacist and having a back-to-back trace of the functionality. Last one is the prescription. And so Filip mentioned 500 patients visiting a pharmacy a day. He forgot a few thousand. It's 500,000 pharmacies, between 500,000 and 700,000 pharmacies, but more or less 500,000 prescriptions at peak moments are being executed on a daily basis nowadays. The prescription, the paper prescription, is being stored was stored in the past in the cellar or the cave within the pharmacies in boxes, and they need to gather that information during a period of 10 years. Nowadays we have the electronic prescription. We decided for the sector, for all pharmacies, not to store it locally in the pharmacy because of danger of data loss or something like that. So what's happening there, all electronic prescriptions being executed, so the proof of the prescription is being transferred to the central archive of the electronic prescriptions. It's also residing on the FarmaFlux side. And the story doesn't end. Mentioned to you that Filip doesn't want to pay or didn't have to pay the full medication cost at the moment he's paying. So there is the so-called third payment system in Belgium. Third payment means that the pharmacists would like to receive some, let's say, payment or some costing back for the medicines being dispensed from the public insurers. To be able to do that, he needs to have a proof of the execution of a prescription and the delivery of a medication, and meaning that also in the electronic work, it's not the paper being used as a proof, but the electronic prescription. So whilst during the day 500,000 prescriptions are being uploaded to the system, during night 500,000 of a copy of the electronic prescriptions are being offloaded to what we call tarification offices, to be capable of billing, let's say, the public insurers on the outstanding amount. Traffic, when you end up and saying 500,000 to 700,000 calls in, because there is a shared pharmaceutical record, the patient enters 500,000 registrations, more or less, on the dispensation. Oh, I forgot 500,000 prescriptions being archived, 500,000 prescriptions being downloaded. So we are up about 2 to 4 million transactions a day in a 24-hour modus, and for that we have opted for the Proximus environment.
Yep.
Right.
Okay, so again, it's a lot of data. We continued working together with the architect team, with the service team, to make sure that the systems that we're hosting for FarmaFlux and APB are running correctly. But this is of course a lot of data that is available in these systems. And Manon, I think you can explain a little bit more what you're doing with that data. I hand you the clicker.
Yeah, thank you. Now, from a business perspective, it's always nice when you have a lot of data available. One of the first things you want to do is you want to create reports, dashboards, you want to gain insights in your data. And one of the first services, that we developed was the follow-up of the dispensation of potassium iodide. Potassium iodide is a medication you can get for free in every pharmacy. It's dispensed and made available by the government, and you have to take it in case of a nuclear disaster. So, and we monitored these dispensations, especially because we wanted to see around nuclear plants if there was sufficient dispensations dispensed to the Belgian citizens. But we also gave the data to the crisis center, the Belgian crisis center, so that they could monitor their campaigns. And you might see some little bubbles here. Those are the campaigns of the Belgian government. And you might see here the big peak. This one is February 2022, and that was the start of the war in Ukraine, where pharmacists were overwhelmed by demands of potassium iodide. Another thing we've seen was the COVID pandemic, and during the COVID pandemic, we had a great opportunity as healthcare workers, as pharmacists, to make a shift from just dispensing medication to offering services to Belgian citizens. And you might remember during COVID, when you wanted to go to visit a restaurant, go to a festival, or go on holiday, you need to prove you were safe with a COVID safe ticket. And it was the first time that a pharmacist was able to touch a patient, and you could go to a pharmacy and he could stick a long stick into your nose for testing if you were COVID safe. Then of course the pharmacist needs to make the registrations, and therefore we created a form that was made available in every pharmacy in Belgium. It was a standardized form where they could put in the data, which we then transferred over the system to Cienzano, Digitaal Vlaanderen, to create the COVID safety kits for the citizens. So it was not only a B2B, but it also became a B2C. That was also a huge evolution for us. But now we are facing another crisis in healthcare. There's a shortages of healthcare providers, and we need to work on a new healthcare system. And one of the things we are building now is working on is population health management by creating also dashboards to make available to the healthcare providers. For population health management, we need a lot of data, not only from pharmacists, but also from general practitioners, from other healthcare workers. Not only healthcare data, but also socioeconomical data and data from local records. And therefore, we need to adapt our system, and therefore we make a technical solution.
Yes. Thank you. Again, we have a lot of data. We were operating in a classical hosted environment with the infrastructure. The end of 23, we started working on the new technology, which is container-based. And actually, Marc, I think you've built a data lake around this available data. Can you briefly explain your project Mars?
Yep. So it's a very nice name, Mars, Medication Analysis and Reporting System. Who invented the name? Thanks, Manon. Now, what we did here is we faced a new challenge. Instead of exchanging data, we needed to manipulate data, we needed to examine data, we need to go into high volume data and data processing. It doesn't work with a simple SQL. So during night saying for a population of 10 million people, let's look a little bit in the data available around these patients and give some results. I can tell you it doesn't work. It doesn't scale up for one. And the sky is the limit, meaning Manon will have a different and additional disease area. They wanted to have further exploration. Full data, the data lake, data warehouse is being constructed and covering the historical data, not nominative, meaning the patient is not known, it's on basis of pseudonymized identification or information itself. To be able to cope with those new technologies and not undefined exploitation or disease area exploration, we said we need some scalability, some flexibility. We said let's put the application infrastructure on a Kubernetes, on a virtualization environment, which is now starting to run. The persistence database and other infrastructure remains in the mainstream environment we have today. Yeah. But there is an addition which is also important. Today, the shared pharmaceutical record is exposed between public pharmacies. Tomorrow you can visit as a citizen also your shared pharmaceutical record. So it's being prepared, meaning that every citizen will be able to access his dispenses, to know it himself, to share it also with the healthcare provider. So coming from a 4,000 pharmacies being connected to the shared pharmaceutical record, I end up to potentially next year 50,000 healthcare providers connecting to the system, 10 million citizens connecting to the system. I needed flexibility, and for that we opted to implement this type of environment. Go for it, Filip.
Thank you. Manon, what's next? What is the future with all this data? Can you explain a little bit?
Yeah. I'm going to be brief because time is running up. Actually now we are preparing not only to be a database or being a data lake, but we are heading to become a health data space. And in Europe there's a wish to create a European health data space, and that's what we're also preparing for, to be able to connect on a European level. I started the presentation by pointing out that it is very important that every citizen should have access to the same level of pharmaceutical care in Belgium. And that's something we want to expand broader than the Belgian boundaries, and the next step will be Europe.
Thank you, Manon. Thank you, Marc. Please welcome me in saying a thank you to these two presenters who willingly participated to bring this session to you. I think I learned even more, even though we were working already a long time together. So I hope you also learned something from this story and how they evolved and their business changed throughout the years. So thank you very much.
Proximus NXT. Think possible.